Fractional distillation is a separation technique that is used to separate miscible liquids that widely differ in boiling points. I welcome you to my YouTube channel. Thank you for coming. Remember to subscribe and give a like to this video. Okay, so we are going to revise this question under organic chemistry. Okay, so the statement above there reads, petroleum is a mixture of hydrocarbons. Petroleum is a mixture of hydrocarbons. In an oil refinery, it is separated into fractions by fractional distillation. In an oil refinery, it is separated into fractions by fractional distillation. The diagram shows a fractionating column and some of the fractions obtained from petroleum. Okay, so I would love to just break down some small words in this statement above. Okay, like hydrocarbon. What are hydrocarbons? So hydrocarbons are compounds of carbon and hydrogen only. Hydrocarbons are compounds of carbon and hydrogen only. So petroleum is a mixture of compounds like carbon and hydrogen only. Okay, so also fractional distillation. The definition I've given you earlier on fractional distillation is a separation technique used to separate miscible liquids, those liquids that mix completely, which means petroleum is a miscible liquid. Okay, so fractional distillation is a separation technique used to separate miscible liquids that differ in boiling points. Okay, so we've got crude oil heated, there is a heater there, and the fractions are the petroleum gases, petrol, X, diesel, heavy oil, bitumen. These are fractions we are seeing here. Okay, so the crude oil is heated to about 300 to 350 degrees Celsius and pumped into the fractionating column. Okay, so this temperature, which is 350 degrees Celsius, is maintained in the column, in the fractionating column. Okay, the first question is saying, state the physical property in which the separation method depends on. State the physical property in which the separation method depends on. Okay, so this fractional distillation depends on a physical property called the boiling point. Okay, so the fraction with the lowest boiling point will tend to be separated first, and that fraction with the highest boiling point will be separated at last. Okay, B. Question B reads, identify fraction X in the fractionating column shown above. Identify fraction X in the fractionating column shown above. Okay, so you should know how these fractions are arranged accordingly to their boiling points. So on top there, yes, it's petroleum gases followed by petrol, and X is called naphtha or naphthalene. Okay, naphtha, or you can also call it naphthalene. Okay, question C. State one use of paraffin and bitumen. State one use of paraffin and bitumen. Okay, so the other name for paraffin is kerosene. Okay, so paraffin is used as a fuel in aeroplanes. Paraffin is used as a fuel in aeroplanes. Paraffin is also used in lighting system, like those lamps that use paraffin. That's the use of paraffin. Okay, so bitumen, also called asphalt, not ansulfat, asphalt. Okay, So bitumen is used in the road construction. Bitumen is also used in roofing. Okay. Question D. Describe the relationship between the number of carbon atoms and boiling points of the fractions obtained. Describe the relationship between the number of carbon atoms and the boiling points of the fractions obtained. Okay, so the number of carbon atoms is directly proportional to the boiling point. What do I mean when I say this? So an increase in the number of carbon atoms increases the boiling points. Okay. So an increase in the number of carbon atoms increases the boiling points. Okay. Question D2. Show the covalent bonding in methane. Show the covalent bonding in methane using dots and crosses. Okay, so how can we show the covalent bonding in methane? Okay, so let us try to draw the covalent bonding in methane. So methane has got one atom of carbon. So we are going to draw a circle. This one is for carbon. Okay, let's put C to show that it's carbon. And also 4 hydrogens. Okay, so the hydrogens should be 4. One here. These should be bonded covalently. Okay, so we can put H here, hydrogen. So each hydrogen atom is going to give 1 electron. Okay, each hydrogen atom is going to donate 1 electron. Okay, so we put for hydrogen we are going to use dots. A dot there, dot there, dot there, a dot there. Okay, and also a carbon atom is going to donate 1 electron in each of these hydrogens. Okay, so for carbon we are going to use X there, X there, X there. Okay, so this is a covalent bond of methane. Remember to share, because sharing is caring. Thank you.